Hey, welcome to the last video in the middle school presentations on statistics. So this is year 9 now. I hope you have enjoyed the journey, and I've got this little bit more to show you now. So let's have a look around the screen, and I've always got a question for you, haven't I? There it is there. When are the columns right next to each other in these column graphs, these vertical column graphs? We've done a few of these in the earlier presentations. Here's one up here, overseas holidays. How many holidays have you been on overseas? A number of holidays along the bottom here, and the number of people who've been on that many holidays. So can you have 4.5 in between these two? Can you have 4.5 holidays? No, you can't. So they're separate columns. They're separated or discrete from each other. And I think we've used this word before, a discrete data set. They are separate or discrete from each other. You can't have something in between. They are separated. All right, what about over here? Can we think of a situation where we have a vertical column graph, but we're going to call it something different now. We're going to call it a frequency histogram because there are no gaps. It is a continuous flow through all the data values. Continuous. I'm going to write that down because that's the subject of this whole video now. It's a continuous situation. The data is not discrete, but it's continuous. So that's when the columns are right next to each other. And I guess you can see down here the sort of values that we might be measuring that are continuous variables. What's time, for example? It's continuous. You can have something between 50 and 60 minutes. You have 51.2, 51.34. You could divide it up in a continuous way, no gaps there. So the variable time would be called a continuous variable. And look at what we've got here. How do we show this? If it was 60, that would be in this group. See the equal sign there? T, the time is greater than, have you done this before? I think so. Greater than 60 or equal to. And then, but it's less than 70. And if it was 70, it'd pop into the next group where it is 70 is less than or equal to t is less than 80. So that's what we're going to be looking at. How to represent data that's continuous and making sure we don't count values twice. We keep them separated, but yet continuous. Oh, that is a bit confusing. We'll have a look at that as we go through now. And over here, well, what are we trying to do here? We're trying to describe the data set as to how even or symmetrical it is. This one's nice and symmetrical, isn't it? Okay, we'll just do this now. Symmetrical. Okay, because, oh, well, there's about the same number on either side of this middle point here. We've drawn a curve through to try and show that shape from those separate vertical columns there. So we're going to be talking about that a little bit as well, about how symmetrical a data set might be. All right, so are you ready for the journey? Let's go now. Okay, and we're going to start with that, describing the distribution of a data set. And screen clippings here are from Hayes and Harris publications in the Australian curriculum for year 9 now. So let's have a look around. Here is our starting point. We're going to say if a distribution is nice and even like that, it is symmetrical. So we've just had a look at that, symmetrical. Okay, so if we have that evenness or symmetry about a middle point, same sort of distribution on either side of the scores, here they are. This side looks very much like this side. We call it a symmetrical distribution. But if one side is sort of out of kilter here, got too many of those, haven't we? It should come down like that somewhere for symmetry. So these are the extras. It's like the negative side has been stretched away from symmetry. So we say that is a negative skewed. The distribution is negatively skewed here. Just get rid of that now. Negatively skewed. Negatively skewed. It's skewed. What does that mean? Well, it's pulled away from symmetry. So what are the extra points? They're over on the negative side or skewed to the left. What about over here? This one, can you see that these are the extra points that are disturbing the symmetry? So it's all about starting with that and saying what's happened. So this is called positively skewed. Positively skewed. Skewed to the positive side. Okay, so remember, number line, that's positive and that's negative. So that's what we're using here. You can say skewed high or skewed low or skewed to the right or skewed to the left, but positively and negatively are the better words to use in mathematics land, isn't it? Or aren't they? Because here we've got the number line idea. All right, so that helps again describe a data set where a graph's worth 1,000 numbers, if you like, and people don't like looking at lots of numbers. They like looking at graphs, and so we can describe what's going on with a few words as well to get a good idea of our set of data. And that's what the whole statistics thing is, isn't it? It's about describing a data set and calculations and things like that to see what's really going on, to answer some statistical question we might have. What about this down here now? What would you say this was? Well, there's two sort of peaks there. So what we call this is bimodal. Bi meaning two, as in bicycle, two wheels. Bimodal, two modes there. So we've got mathematical words here that can easily describe what's going on. And it's good, isn't it? Maths is pretty precise with its language. Let's go on now and have a look. All right. So here we've got a bit of data here. Now this is discrete data, isn't it? Number of visits to the doctor. So you can't have 1.5 visits. And how many times did people go no times to the doctor? There were 6 people who went no times to the doctor, didn't go at all that year. Once there were 8 people. And so it was a total of 45 people were all asked how many times they went to the doctor. So let's display it on a column graph, and here it is down here. And there'd be gaps, wouldn't there? Because you can't go 1.5 times or 2 1/3 times. There are going to be gaps in between here where you couldn't go that many times. So there's separate and discrete data here. Oh, hang on, let's go back. Discrete data. Separate columns. Okay, and we want to describe the distribution of the data. And we're going to say it is skewed high or positively. See, here's symmetry, and these are the extras the other side hasn't got, if you like. So that's what's skewing it away from symmetry. So basically, when we say it's positively skewed, what we're trying to say is how does it vary from the nice symmetrical position? Has it got extras on the right, on the positive side, or has it got extras on the negative side? Hope you get that idea. Okay, let's go down and have a look, and you can practice here. A lot of this video will involve things that you've done before, so with just a few added pieces, like describe the distribution here of the data. So you might not do all of these questions, but just a few of them. So pause the presentation as usual and have a go, and the answers are coming up a bit later on, so you might have to scroll forward to see if you're getting them right. Okay, here's some more for you. 8 questions, I think that's the total now. And there we have the answers. Okay, so check it all out and get this idea of skewed distributions or symmetrical distributions and all that stuff. Okay, let's go on now. Okay, so here we are. This is the first presentation where we've looked at a different type of graph. It's a vertical column graph, if you like, with no gaps. And so here, I just do this. I don't like that business coming up there. So here, there's no gaps. It's continuous. It's a continuous variable. So there are no gaps between the possible values you can have. And so this is what this presentation is predominantly about. So something like the weight of 17 pineapples was recorded in kilograms. The weight in kilograms. Can you see there's all sorts of variations here? 1.5, 1.92. You could have any particular weight, couldn't you? Not just 1 kilogram, 2 kilograms, 3, but everything in between. So we're going to have to organise the data into class intervals. So we go, maybe we got the light ones from 0 to 1 kilogram. Okay, so there's our first one. Look at these symbols here. It means if it was 0 weight, which is silly, it wouldn't exist, then that would be in the first group because of that equals, right up to 1. But once you get to 1, there it is, the equals there, it's in the next group. Do you get the idea? We have to have a system or a symbol to cover all possibilities right up to the next value. So we have to choose where to put 3. Well, 3 kilograms wouldn't be in that group, that says less than. And it would be in the next group because 3 is less than or equal to the weight of that group. The weights in that group are greater than or equal to 3. So just to check up on that, so when we have 3 is less than the weight, it means it wouldn't be in that group. But if it is less than or equal to, that means that group goes from 3, including 3, up to 4, but not including 4. So something like 3.9 would be in this group, but 4 would be in the next group. Can you see this tricky little way here of making sure there aren't any values left out? And of course, when we draw the graph now, so we go through and again do a tally column, and get these numbers, just scan the data once, and they haven't put in a tally column, but we'd normally put in a tally column there, wouldn't we? And then a frequency column. And now look at the scale here. We are going to go from 0 to 5 kilograms, and you could have left this gap out. You could bring that up to there, but the important thing is there aren't any gaps between here. Every possible weight could be included there by the way we've set up our table over here. I'll tidy this up a bit here. So the way we've set this table up, this frequency table, is every possible score has been included, and there are no gaps in our representation of a continuous variable. And the weight in kilograms is a continuous situation, isn't there? It could take any particular value. Okay, what's the modal class? The one that occurred most frequently. So that's this dude here. So it's a class of reading this, the weight is greater than or equal to 1 kilogram but less than 2. So we say the weight is between 1 and 2 kilograms. Okay, get the idea. So this is new, and this takes us on to, I suppose most variables in our world are continuous. Heights, weights and things, lots of continuous variables. All right, let's go on and give you a go now. So here we are. There's one that has been already done, and here's one down here for you to make up for or to graph for yourself. Have a look at this here. This little dude is saying there's a little squiggle in there because the values start at 50. You can't start them back here at 0 because they start at 50. So you're going to break the scale so you don't have, what, a big gap and the graph's out here somewhere. Okay, so we're going to condense this up. And to show that, we put a squiggle in there. Okay, just get rid of this. So here, so that it's not way out further down the scale, we'll say, well, that, and then we'll start it here. But then from then on, the scale is more condensed. We don't want huge gaps here according to this 50 scale. We don't want a big gap in the scale representing 50. Okay, so we condense it up a bit. All right, so that's what that is about. You might need to do that down here because look at this, it doesn't start until 170. So you might have to use one of those little squigglies there. All right, pause it, have a go, and as usual, we'll have a few more problems and then the answers are coming up. Okay, here's some more questions for you. This is new stuff, so I think you should do all of these. And there are some answers. Okay, so practicing two things: continuous data plotting and frequency, getting a frequency table, and also skewness or symmetry and describing the distribution. All right, let's go on now. This is a bit of revision, and because why are we doing this then, you might say? We did it all before. You've seen these definitions here before. We're doing it because now we're working with a continuous variable. So how do you do the mean and all that stuff with a continuous variable? Now, here's the word definition, but we've been using this, haven't we? This is important, I think, to use these. Remember, it's the same thing. Sigma, Greek capital sigma, means sum of in maths. The sum of all the x's, all the scores that we have measured, the data points, divided by how many there are. And over here, similar sort of thing, but you've got to remember to multiply by the frequency. So you're going to use this one when you have a frequency table and the scores occur more than once. Okay, so you know about that. Now down here I've got something a little bit different. The median is the middle value of an ordered data set. Now the book says this. I want to change this a little. If there are n data values, find the value of m plus 1 on 2, and the median is the m plus 1 on 2th value. Well, we have to modify that a bit. If n is 12, n plus 1 on 2 is 13 on 2, which is the 6.5 value. Now, we don't actually do that, do we? We don't have a 6.5 value. Okay, what do? We take the mean or the average of the 6th and the 7th values. And you might remember way back when these videos on calculation of statistics started, this one was on the screen, and we're finally going to have a look at it. This is the median, a half, so it's the average of the x n on 2, that's this one. The average of the 6 and the 6 score and the n on 2, not n plus 1 on 2. So this is the 6 score and the next one, the 7th score, n on 2 plus 1. So that's a complicated looking formula, but it's not really, is it? We're trying to put it into a formula so that we don't have this problem here, because this definition is not complete. That actually doesn't work for even ones. There isn't a n plus 1 on 2th exact value. It's a 6.5, and we say take the mean of that one and the next one. So let's do that. Find n on 2, that'll be the 6th one, and then add 1 to it, that'll be the 7th one. So there's a formula. That's a bit complicated for year 9, but I think you're good enough, aren't you? I think you can handle that. So that finally explains that all the formulae that were on that first page when we were saying about calculation of statistics. All right, so we have to do this now with group data and stuff. So let's go down and have a look. So here's some revision. So you might not do all of these. This is just a bit of revision from before. So pause it and have a go at a couple. Let's go on now to a few more. And again, just remembering stem and leaf plots, make sure you have a scale and you understand the scale as you use those. And then we have up to the 12th problem there, and you might have a look at that. Okay, and here are some answers. All right, so I hope you're getting some of those correct, because this is basically revision now. Now what we want to do is to move into some of the work with group data where it is a continuous variable. So here we are, the speeds of 129 cars were measured in a particular point, at a particular point on a country road. They're shown alongside here. So here we are, speed. Some were travelling equal to 40 or more and up to 50. Then if they were equal to 50 or more, you put them in that group. Okay, got the idea of these signs now. Very, very important to make sure we cover all possibilities with a continuous variable. Okay, so these are the number of times, hang on, we'll just go back in. These are the number of times that people went those various speeds. So we would have had a tally column if we had the raw data there at the beginning. Okay, so what are we going to do now? We don't have the actual scores. No actual values here. They've been grouped up. So what are we going to do to get the mean? We don't have the original values. So we're going to make an assumption. So this is estimating now. Come up the top. Estimating the mean of group data. Because the data set has been lost, it's been grouped up, and now we don't have all the individual scores. So we're going to assume each one of these three were all equal to the midpoint of this group. So that's an approximation, it's an estimation. So what do? The two endpoints, 50 plus 60 on 2 is 110 on 2, which is 55. We're going to assume, to get the total of that group the same, that there are 3 lots of 55. 3 lots of the mean of that group. Okay, so that would give you the same total score for the group as all of them added up. Okay, so here we have 3 lots of 55, so we're going to say the total of that group is equivalent to 165. We're assuming here. Not good, but we can't do anything else. We've lost the original data set. Okay, so the mean here is the sum of the data values. Okay, well, I reckon you've got to go x bar equals the sum of fx on n, don't you? All right, now you're into big time. You can do that. You're year 9 here now. So we want to add up all the values of x. So it's the frequency times the midpoint and getting an answer. Okay, because just remember they all occur a different number of times. So there's 39 lots of 75. You can't just add up these. They occur a different number of times. Got that one? We've got that. We had that before. All right, so here, what's the total of all those? And how many scores are there? There are 129 cars. So those midpoints all occur a different number of times. And there's the total of 129 cars there. So to 3 figures, it's approximately that because we're estimating it, right? So this time, this is an estimate. So that's approximately, and then you round it off. So it's approximately 80.3 kilometres an hour to 3 significant figures. Do you get that idea? Okay, so here's something new for you. The idea of when the data has been grouped, we don't have the original values and we've got to estimate them with the midpoint. Let's do some. Okay, so here we are. Have a go with the data set they've produced for you here and see how you go with all the things. Here you want the mean, the median, and you could also have the modal interval, modal distance and modal group if you like. Okay, pause presentation and have a go. And the last question is that one there. And let's have a look at the answers. And there are our 4 answers. So how are you going? Interesting, isn't it? When you have group data, what you have to do to describe it, what's going on there with statistical calculations. Let's go on now. Okay, so what are we going to do? Well, you would have guessed it by now, I suppose, measuring the spread of a data set. So again, it's a bit of revision, but there's something new here too. The range is what we've used before, the maximum data value minus the minimum data value. And so when might that be a bit misleading? What about if you had really skewed data? Hang on. Really skewed data, and most of it was here, and you could make it continuous or discrete here, but let's say it looked like that, and so there were too many down the bottom here, let's say. So that gives you an impression that the data is really spread out, but it's not, is it? And most of it's in here. So the range might be a bit misleading, taking the highest minus the lowest, because there's only a dribble of points down here. So is there a way of describing the spread with perhaps the range in another value as well, indicating that basically most of them were bunched up in the middle? And you've got it therefore, haven't you? Interquartile range. Ooh, what's this? Upper quartile minus lower quartile. So what we're going to do is, instead of dividing the data set into two halves split by the median, okay, so let's have a look. There's a data set there. And where's the median? There it is, 5. We're going to divide the lower quarter and the upper quarter, or lower half and upper half, into quarters. So we're going to find the middle of the lower half and call that Q1, the bottom quarter, and Q3, the top quarter, or 3/4. So if you were to draw it, you've got a whole lot of data points. You've got the median in the middle, which you could call, what, Q2. Halfway is the second quarter. And then we're going to divide it up here, bottom quarter and top quarter. So it's the third quarter from the bottom, Q3. Okay, that's an upper quarter, or 3/4 of the way along. And Q1 is the bottom quarter. Do you get the idea? And what we're going to do now is to try to describe the distance between the upper quarter and lower quarter, or the middle 50%. So that's going to do this job for us up here, isn't it? If the middle is really quite tightly bound, it'll have a smaller interquartile range, or the distance between the upper and lower quarters. So it's not a bad system. We're going to split it into quarters, our data set, and then take a measure of the middle 50%, or from the lower quarter to the upper quarter. Now, that's not a bad system of overcoming this problem up here, is it? Of where there's a dribble on the top and the bottom, but most of it's in the middle. We should have a rather small interquartile range, IQR, the upper quartile, which is the score that's got a quarter above it, minus the lower quartile, which is the score that's got the bottom quarter below it, or got the lowest quarter below it. Okay, so here, what would it be? Well, if we found the 2 here, it would be 7. In there, take 3. So we're going to do some more medians. We're going to split the data into halves using the first median, then find the median of the lower quarter and the upper quarter and see what the spread is in between those two. So this is not a bad system at all if you have this sort of setup here, and we'll just go back, this sort of data set here, where we want to describe the fact that really the data isn't all that spread. We've got some dribbles off the top and the bottom, giving probably a false impression of how spread the data set is. Do you get it? You might talk to your teacher and classmates about that. That's an interesting variation now in measuring the spread of a data set. Okay, let's go down and have a look at an example. So here we have the data set. Find the median. Well, that's okay. We've got to put them all in order. There they are, all in order, and there's 20 data values. So we're going to find the 10th, and we'll divide by 2, we'll get the 10th. Okay, 20 divided by 2 is the 10th, and the 11th value, halfway between those two. Or the 10.5 if you want to do that, and that indicates 10 up to the 11th value. So that is the 6 and the 7 there. So our median is 6.5. So that means we're going to split it there, and there isn't a 6.5, obviously it's halfway between those two scores, but we have successfully got a lower half and upper half. Now we're going to do it again. We're going to find the middle of this lower half. So how many scores are there here? There are 10 scores, are there? I think so. 10 scores in the bottom half. Count them up. Are you happy with that? So it's halfway between the 5th and the 6th score. So that's there, halfway between those two, which is just 4, of course. And halfway between these two is 8.5. Okay, so what's the spread of the middle half of our distribution between these quarters? Okay, what's the overall spread? We're trying to describe to people that now, that gap there. and it's Q3 minus Q1, which is 8.5 minus 4, which is 4.5. What would the overall range have been if we just stuck with that? What would that tell us? The range would be the highest one minus the lowest. It would have been 12. Okay, so that gives the impression that it's pretty spread out. When overall, in here, you've got most scores, if you like, the middle half, and they aren't that spread. The spread is only 4.5. Okay, so there you are. And just take note here, this little fellow is saying some computer packages, Excel is one of them, calculate quartiles in a different way from this example. And at the end of this presentation, there will be another video on how to use technology with calculators and Excel. So have a look at that. All right, so let's go on and see if you can do some of these. So we'll have to do most of these questions, I think, because you haven't seen this before, so you need a bit of practice. So pause the presentation and have a go. And the last two questions. And let's have some answers. So there are the answers. All right, how are you going? Hope you're getting the hang of this. Let's go on now. Okay, so we're nearly at the end of this presentation. We're going to do some graphing to compare numerical data. Okay, it's got measurements or numbers in it. So we've got a few different possibilities here. We could do a comparative vertical column graph. Okay, so the green is one set of data and the buff or yellowy colour there is the other set. Or we could do a combined bar graph, bars opposite each other. Or this is quite good because it's got the actual data set there, and that's comparative stem and leaf plots. So this was one data set and this was the other, and we put them opposite each other so we can compare what? Well, that's pretty symmetrical, and so is that. This has got more in the 90s. No, this is 6.1 in the 9s. So that's handy, isn't it, to be able to compare data sets in any of those ways. They're all good ways. Okay, so come down and let's have a look. Here's one that's been done, comparing Sam and Kate weekly spelling tests. So spelling tests, you either get them right or wrong. So there are gaps, aren't there, between these points here because it's discrete data. You can't have 19.5 spelling tests correct. You can't have 19.5. You either get the word correct in its spelling or you don't. So there are gaps. It's discrete data. So I'll write that down. It's discrete data. And so there are gaps. So how many times did each student score full marks? So we're looking at the top here. So 20. So Kate did it 4 times and Sam scored it twice. Describe the distribution of each data set. Well, let's have a look. We better try and see Sam. Sam is like that. So it's skewed. You've got extra points up the top end. That's positively. And now Kate is like that. So basically she's symmetrical and Sam has got a tendency to be lower but with some higher score, so it's positively skewed. So the extra data points are up the top end, so that's good for him. It's better having the extra scores being higher than lower, so he's positively skewed. The range of Sam's marks, well, let's tidy this up a bit. It's getting pretty messy over there. So Sam's marks is he did get some 20s, the range, and his lowest was 12. Notice there's a gap there because the big gap between 0 and 12, so we just put a squiggle there. So it's 20 take 12 is 8, and the range of Kate's marks 20 take 15 is 5. So what can you say overall? It looks like Kate is more consistent because she only ranges over 5 marks. Okay, from the column graph, Kate has more scores at the higher end. So the fact that you've got more red up here, red up there than blue, suggests that Kate scored high. Comparing the ranges, it looks like Sam had the greatest spread of marks, and so he's not as consistent in his spelling, is he? He can range or vary over a greater number of correct than what Kate has. Okay, so thinking about those interpretations of the statistics that we are using here to compare data sets. Okay, have a go. Here's some for you, and you can, in this case, start practicing the interquartile range. So you're going to have to find the median and then split it into two halves and then into quarters using the median of the top and bottom halves. Okay, so there are a couple of questions. Pause the presentation, and here are some answers. Okay, so I hope you went well with those. Well, let's keep going now and have a look at some other data sets. And what we're going to do here is we're looking at before and after advertising, how the restaurant is going to go. So here we are. He records the number of customers in his restaurant for 30 days before he starts advertising, and then for 30 days after. So that's before and that's after. How did the advertising work for him? So we're going to use the actual data values and no grouping or anything. So it ranged before advertising from 56 customers, and here we are. The scale down the bottom, I must always put that, up to 94. And then after advertising, he never got less than 67, and he went up to 108. All right, so laying it out like that, you can see a definite move that way, upwards, after advertising. Okay, now whether that's profitable enough is a different question. Find the mean of each data set. So you have to add them all up, and all the scores are there, aren't they? 67, 69, 70, 76. So you're going to actually have to lay them all out and add them up before and after advertising, and then divide by how many there are. So he's done 30 customers, or the number of days, 30 days before and after advertising. So dividing by 30, that's the average number of customers. So it's gone up quite a bit. Discuss the effect of the advertising. It's increased by approximately 16 customers per night, because this is the average over 30 days, isn't it? Or 30 nights when he opens a restaurant. So this is a daily average. So it's gone up by 16 customers per night as a result of the advertising. So he'd have to work out how much advertising cost and whether the extra customers were worth it, because advertising might have been very expensive. Okay, so we're getting into interesting stuff now, aren't we? So people can actually use this to analyse their situation in business. Okay, let's go on and give you a chance now. So here are a couple more questions. We have to leave that one out because I didn't include that in the video. So we'll just do question 4 and do a back-to-back bar chart here. Or you might like to do a comparative vertical column graph. Do a couple, see what you think. Okay, so let's have a look at another couple of questions. Here's another chance to do a back-to-back stem and leaf plot to compare. So you might need to do that because that's something new that you haven't done before. All right, so let's go on. And 7 and 8. And there are some answers for you. Okay. Question 4, 5, 6, 7 and 8 down there. Okay. We're nearly at the end, so hang on in there and see how you go for this next little section. And we're finishing off with something we've done before, again, data collection. A census involves collecting data about every individual in the target population, and a sample involves collecting data about a part of the target population only. We've done quite a bit of this, and the reason why we can't do a census quite often is because of the time, the cost, and sometimes, for example, testing light globes, you can't test them all because testing them, how long they go for, will wear them all out and you'll have nothing to sell. So there's lots of reasons why a census is not possible. And the sample, of course, must represent, as we saw in the last video, must be a representative of the whole population that you're going to be talking about. Okay, let's go down and do a bit of revision. This is revision now, isn't it? State whether a census or a sample would be used to investigate these things. All right, so let's go on. Here's something a little bit different, but pretty much the same as what we've been doing before. Okay, just a few variations there. And up to question 8. Okay, so just a little revision, talking about bias and that sort of thing, and whether the estimates are reliable. Okay, so let's look at the answers. Okay, so there are the first 6. Just think about some of these worded questions here, or questions we're asked to discuss stuff. Okay, and think about whether the sample is going to work for you or not. Okay, let's have a look then. The final one is that little bit there. And so I hope you've enjoyed this presentation. That's the last one. The ones coming up are to do with technology and the calculation of statistics and drawing graphs and stuff with graphics display calculator and Excel spreadsheeting. So I hope to catch you in those. Cheers for now.